Let's go back to inverse calculations. Important to inverse calculations is knowing the climate sensitivity to carbon dioxide forcing. Climate sensitivity is how responsive the climate system is to some forcing, for example, an increase in CO2. And we usually determine climate sensitivity for a doubling of carbon dioxide. Climate sensitivity is an area of uncertainty. This table shows the likely range of carbon dioxide concentrations that would lead to different global temperatures. The table shows that for an atmospheric concentration of CO2 between 320 to 380 parts per million, there is a 66% chance temperatures will increase by 1 degree Celsius. And for atmospheric CO2 concentrations of between 370 to 540 parts per million, there is a 66% chance temperatures will increase 2 degrees Celsius. So this means if we want to keep the concentration of CO2 to between 320 to 540 parts per million in order to keep temperatures below 2 degrees. The only way we're going to do this is to make deep cuts to carbon dioxide emissions. Here, carbon dioxide emissions are shown in the upper plot and the concentration of carbon dioxide in the atmosphere in the lower plot. Time is on the x-axis going from 1960 to 2100. To stabilize emissions at 540 parts per million by the year 2050, this is shown in green, we need to reduce emissions by at least 80% by 2100. If we only stabilize emissions, meaning we're still emitting CO2, and we will continue to increase the concentration of carbon dioxide in the atmosphere as shown in blue in the bottom plot. In red, we see what happens if we do nothing. Clearly, not the preferred path. This slide contains state-of-the-art understanding of what we need to do. Panel A shows a plot with time on the x-axis and temperature on the y-axis. The initial line in orange and gray is estimated global temperature until 2017. The gray panel shows the likely outcomes of temperature if we reduce emissions to 0 by 2055. The green panel shows what happens if we reduce emissions to 0 by 2030. Faster reductions increases the probability of successfully keeping temperatures below 1.5 degrees C. Both the gray and green panels include reductions in both carbon dioxide and other greenhouse gases. The purple panel shows only reductions in CO2 and results in higher or lower probabilities of keeping temperatures below 1.5 degrees C. Both the panels on this slide and the panel on the last slide show emission scenarios that we could take to keep the planet safe. All of them require a dramatic global effort to change the path we are presently on.